All right, so I wanted to go over this complicated shape one because, well, real quick, centroid is basically a fancy way of saying center of mass. So normally on an easy shape like a rectangle or a square or a triangle, they're pretty easy formulas, and you had that in your guided notes. But what do you do when you have a crazy shape like this? I wanted to kind of walk through how to solve a crazy shape because your homework worksheet is like this too. Basically, what you can do is divide your crazy shape into simple shapes, right? So if we divide our crazy shape into simple shapes, then we can find the centroid of each one of these shapes. So here's like a picture of it. And if we find the centroid of each one of those shapes, you basically have to consider how big the shape is, and that it's sort of like a weighted grade. If it's a bigger shape, its centroid position makes more of a difference than a smaller shape centroid position. And you can find the center of mass of the entire thing. So before you get going too far, you always need to determine reference axis, also known as your 0, 0. Okay, so like on this shape, I always try to pick the bottom left corner because if I do that, then I'm not working with any negative numbers. Any distance I go to the right will be a positive. Any distance I go up will be positive. And then after we find our 0, 0, we're going to calculate the area of each simple shape, because the area, how big it is, will determine how much of its centroid makes a difference. So these are all pretty simple shapes, right? Shape 1 is just a rectangle. And if you look at the dimensions that are in your notes, it's a 3 by 6 rectangle. So the total area is going to be, well, width times height for a rectangle, 18.0 inches squared, right? And then the second shape is a triangle, right? Shape 2, and its base is 3 inches across, and its height is 3 inches, and the area of a triangle is 1/2 base times height. So 1/2 times 3 times 3 is 4.5 square inches. Okay, and the third shape is a square, which is cool because that's a really easy area. So you have 3 by 3 square, so you get 3 squared, which is just 9 inches squared. So with each of these, the bigger the area, I was saying, the more pull it's going to have on the center of mass. If you had a little shape, it's not going to make that much of a difference. So determine the centroid of each simple shape. So we're going to find number 1 centroid, and we're going to find number 2 centroid, and we're going to find number 3 centroid. We'll come back to the areas later. Okay, so basically, since number 1 is a rectangle, you can find its centroid from your notes. You had the centroid is just of a rectangle, super easy. It's just halfway on the x's and halfway on the y's, right? So this is for a rectangle or a square. If I know the whole distance, I know the x part's halfway. If I know the whole height, I know the y part's halfway. So on this guy, the centroid part of shape 1 is 1.5 over, because that's half of the x, and the y part is 2, or not 2, 3 up, because it's a total height of 6. Okay. Similarly, on shape on the square, the centroid of this guy is 1.5 over, but be careful because the whole distance here, you're going from 0, 0 every time. So our first shape was easy, but if I want to know the position of my centroid of this guy, I wouldn't say 1.5, I would say it's 4.5 inches over. Because yes, it's 1.5 in from this side, but I already moved 3 over. So it's 4.5 inches over. And its height really is still 1.5 because 0 is your bottom line. So we're going to have that. So let's start writing these down. Let's see, the area of shape 1 from up above was 18.0 inches. the area of shape 2 was 4.5 inches squared, sorry, and the area of shape 3 was 9.0 inches squared. Okay, now xi, that means, hold on. So when you see xi, this is just the x part of the centroid, the center of mass, for each shape. So on my first one, remember, it was over 1.5. And then on my, we'll look at the third shape, the square. Remember, it was over 4.5 inches from my 0, 0. There's 1.5 in, but I already had 3 inches over, so 4.5 inches. Now we get to the weird shape, and that is your triangle. The formula for your triangles centroid is a little different. It's not as common, but it's a third of the way from the right angle part. And be careful, because sometimes you'll get a picture where the triangle's flipped over. So the x part is a third of the length of this x from the right angle. So on this one, here's my right angle. If the whole distance is 3, it's only 1/3 of the way there. Well, that's a nice easy number, because a third of 3 is 1 inch. Now, be careful though, because you already went over 3 inches here, because I want to know from 0, 0 how far to the right is it. And it's 3 inches to the right. Okay, and we're going to do the same thing with the heights. So once again, our areas haven't changed. This one's 4.5, and this one's 9.0. So my heights of the original one, this is my 0, and it goes up halfway, which is 3 up, right? 3.0 inches up. My shape 2 is the triangle, so it's already 3 up, and I need to figure out how much higher it is. And kind of the same deal here. The y part, or the height, is 1/3 of the total height from the right angle. So here's my total height from the right angle, 3 inches. What's 1/3 of that? 1 inch higher. But remember, don't write a 1 here, because from my 0 line, it's a total of 4 inches high, because 3 for this and 1 more inch. So 4 inches. And then your last one, the height of this guy, since this is my 0 line, it's 1.5 up. Okay, so that's pretty easy. You did it for the x's, you did it for the y's. Each shape gets their own formula. So determine the distance from each simple shape's centroid to the reference axis. We just did that. That was from 0, 0. That's why we didn't write a 1 here, we wrote a 4. Multiply each simple shape's area by its distance from the centroid. Okay, so basically, this is like our weighted grading system. You're going to take the area times that guy's x part. You're going to take this area times that guy's. It's basically pulling the centroid in different directions. So bigger shapes have bigger pull. So if I multiply these out, I get 18.0, or 18 times 1.5. I get 27, and my units are inches cubed, which is weird. My next one, 4.5 times 3 is 13.5. So I'm going to go through and do those for my x's. I'm just taking that times that. And see how this is written? It's area times x part. The little I is just a subscript. Okay, so I'm going to pause for a second and do the math. Okay, so now what we're going to do is take the sum of each simple shape's area. We're going to take the sum of the x's and the sum of the y's. Those things we just came up with. So I'm going to make the sum of that, the sum of that. Okay, because this is area times the x part. It's basically going to make our weighted grades. So if we look at this and I add up 27, 18, 40.5, you get a total of this. And it's important to keep track of it, that this is the sum of the x parts times the areas. If you read that down there, this is a little symbol for sum, and that's A with the xi. And then this one is another one that's the sum of the y's, area times the y. Okay? And then finally, we also need the sum of the areas. Okay, so if I just added up my original areas, this one, and this one, I get the total area. So basically, we're giving it a weighted grade system where I took this times its area, this times its area, this times its area, and I'm going to divide them all by the area to get kind of the average of it. And that's what this final one is all about. You're going to divide the sum products, which we just found out. There's the y's, there's the x's, there's the areas, by the summed object total area. So we're going to take the 85, here's the y one, the 85 one divided by total area. You get 2.71 on the y's. The 85 on the x's divided by total area. You get 2.71 on the x's, so we go right 2.7, up 2.7, and that is the center of mass. You can do that with any shape. Any complicated shape, you can do it like that. So, there is a different way of doing this problem. I think I missed a word back here, the sum products. Okay, sum the products, and this was the summed object total area. Okay, so there's an alternative solution, a different way of doing this problem. Depends how you look at it. So if your eyeballs saw this as a square and you removed part of it, that's called the subtractive method. It's probably easier this way, but I wanted to show you the other way because I'd say more often you do the additive. The other way is adding chunks together. This is taking a chunk off. So if you're going to do it the subtraction way, you find the area of the giant shape, and then you just make the area of the piece you're cutting off a negative number. So when you look at this, the whole shape 1 is the whole thing. That would just be a 6 by 6 square, or 36 inches squared. The area of the other piece is a 3 by 3 triangle, and 1/2 base times height would say that's actually 4.5 again, except it's negative. And it's negative because you're removing it from the picture. You don't want to use a positive here. And then you got to find the middle of the big square, which is 3 over for x's. And the middle of this guy, be careful because it's 1/3 of the base, but it's from the right angle. So it's 1 inch this way. So total, if the whole thing would be 6, this is actually 5 inches from my 0x. Similarly, this is 1/3 of the way down because my right angle's up here. So I want to say my normal height would have been 6, but it's 1 inch less. So it's going to be 5 on the y's too. Okay, and here, what's the height of this? 3. Okay, my areas are still the same. 36 inches squared, negative 4.5 inches. So that's the hardest part, is to remember that negative thing. Okay, so now we're going to multiply those together. I'm going to pause it for that. So on there we got the 108 cubic and the negative 22.5. And we can do that final step the same way we did before, where we add their products, and you get 85.5, and you add the product of these, and you get 85.5. Then you add the areas, and you do this final crazy step, which is a formula where you take the total of the y's divided by your area sum, and you take the total of the x's divided by the area sum. And you still get the same exact spot as we got the other way. So it's kind of like whichever your brain sees you can do. That way seemed a lot faster. But there's other times where the subtractive method wouldn't be as useful. Alright, so hopefully that helps. We'll get into all these other I-beam kind of shapes later. So, alright, talk to you later.